All right. Good evening, everyone. Welcome to this training on ProtaStructure. So this training is organized by Royal Grant Engineering Trainees, um, and this is the training on ProtaStructure. So during the course of this 1 month free training on ProtaStructure, we are going to be teaching you all the basics. We are basically going to be covering um, the steps, everything that you need to know in order to get your to know your way around the ProtaStructure environment and become familiar with it. So after this free training, we are going to be covering an advanced training. Okay, so in this advanced training, we are going to take our time and go slowly step by step in order to teach you everything that you need to know, along with some um, manual and guiding principles with what you need to know about the structure design that is going to help you in your structural design and analysis. But in this 1 month, in this free training, what we are going to be covering is going to be enough for you to do some basic modeling and structural designs. Okay, so about me, I'm Kenechukwu Kingsley. I'm a training instructor in REnT for ProtaStructure. I have years of experience as a designer and as a structural engineer and also as a training instructor. So about us, Royal Grant Engineering Trainees, REnT in short, we are committed to offering excellent trainings designed to meet current industry standards and career demands. We provide the resources and directions that enable aspiring and working engineers, including students, undergraduates, graduates, and even working professionals to succeed in any of their chosen engineering field. So what that simply means is that what we do in Royal Grant Engineering Trainings is that we offer excellent trainings. So we train young engineers, whether you're a student, undergraduate, graduate, and even if you're a working professional. So we provide you with the prerequisites, guidelines, and trainings that is going to help you excel in any of your chosen field and that is going to help you upscale yourself in the engineering industry. Okay, our goal is to bridge the skill gap in the workforce by making professional trainees more accessible. So we aim to make professional trainees very accessible to everyone, irrespective of their location or maybe background or anything. Okay. Secondly, we train you on engineering software in a simple to understand manner. So we train you on software in a way that you're going to comprehend that very well. So when you train with us here in REnT, you find out that you actually understand how to use your engineering softwares very okay and very perfectly. Then we train you to become a professional in using building information modeling platforms and computer-aided design platforms without leaving the comfort of your home and office. Then we also help you in achieving your goal of enhancing and acquiring new skill. Okay, so problems that we are solving. Many professionals who want to acquire new skill in their career face significant challenges, and one of these challenges that they face is lack of time. Traditional in-person training often conflicts with work schedules. So if you are a student, let's assume you are an undergraduate and then you want to engage yourself in some of these trainings, professional trainings or software trainings that is going to help you in the long run in your engineering field, but you are still a student, you are going to find out that the time that is going to be required for you to be attending these trainings oftentimes conflicts with your academic schedule. So wanting to engage in these trainings anyways is going to force you to be skipping lectures and stressing you out and all that. So it is a problem and we are out to solve that kind of problems in REN so that even if you are a student and you want to also engage yourself in trainings, you can still do all of that um, without disrupting your schedules, maybe your working schedules or your academic schedules. Then another problem is limited access to quality training. Yes, many professionals or many students may not have the kind of access they would want to professional trainings. Even if they have access, they don't really have access to a very good professional trainings. So it's a very disturbing problem, maybe due to location or background and all that. So it's a huge problem, and we are also out to solve that problem as well. So our solution is that we provide flexible, high quality visual training programs that are designed for professionals who want to enhance their skills without disrupting their work. So by offering industry relevant training online, we ensure that professionals can learn from anywhere, anytime, and at their own pace, solving the challenges of time constraints, accessibility, and affordability. Well, that is very, very simple, and that is very, very understandable. Okay, so most of our trainings, we actually perform them virtually, that is online. So having our trainings online um, automatically solves the problem of inaccessibility of training. So as long as you have a device, maybe a laptop and an internet connection, you are already able to access our trainings. And in addition to that, our trainings are very very affordable. So it's very very rare for you to see a very affordable training, a professional one, and a very very and it will be very very accessible. So and in addition to that, we are also solving the problem of time constraints. So due to the fact that we are having our trainings online, and we also try to schedule our training aligning it with the schedule of our participants or students. So when you are training with us, you get the option to schedule yourself and also schedule your training as well, so that it can be very very convenient for you. Okay. So moving on, our services. So the services that we offer in REnT, we offer card simulation services, card training services, card consulting, card modeling, then building information, modeling and simulation, card support services, and other card related contracts. Then we also offer in-house and private training programs. So our mode of training. So here we have the virtual classroom training, just like a virtual classroom setting. So we also offer a training just like that. And here we have online training, just like we are possibly having now. So we can also train online, and then in-house training. You don't want online, maybe you want it physical and all that. So we can invite you to our office, and then we can schedule a class for you, and then you can have a more like a physical training meetings and all that. And then private trainings, you don't want those kind of trainings that is going to be crowded, so you want your own private trainings. So you can also contract us, and then we can teach you privately on any software that you would want. And here we also have corporate trainings. This is for maybe companies or corporate companies. Let's assume that you have staff who are lacking some prerequisites or skills that are going to be needed in your engineering company. So you can actually invite us, and we take few of your staffs and train them in what they need to know, maybe engineering softwares and all that. That is going to help your company in the long run. Then we have campus trainings. This campus training is very very important. So for universities, so let's assume you have your SUG, departmental president and all that. So you can organize a kind of a campus training on softwares or engineering softwares and all that. So then you can invite us to come and take students on different engineering softwares. Okay. So moving on, here we have ProtaStructure. So many of us might have been hearing this software or this name. So some of us know what it is used for. Some of us done. So, but in case you are hearing it for the first time or you don't know, ProtaStructure is a structural modeling, analysis, and design software designed for reinforced concrete and steel structures. The software is developed by ProtaSoftware. So this simply means that ProtaStructure is a software that is generally used by um, structural and civil engineers to analyze and design their building members and the building um, actually. So it allows users to model, analyze, and design buildings quickly and accurately, often incorporating beam integration. Okay, so what that simply means is that ProtaStructure can provide you with reliable design informations that can be created, exchanged, modified, and updated throughout the design process of your building. Okay, so this information I'm talking about is like your bar bending schedules, your detailings, your design reports, calculation design reports, even your bill of quantities and all that. So it can be generated automatically using the software ProtaStructure, but nevertheless you will still have to make a few one or two changes in order to have your reports and detailing as you would. Okay, so ProtaStructure offers tools for various structural elements, including beams, column slabs, foundations, and support diverse design codes and standards. Okay, so here it supports various analysis methods, including P delta analysis, and allows for the design of steel and concrete structures. It also allows users to create models by defining members and importing from beam links. So um, it allows you to import and export members from BIM platforms, just like your Revit and all that, 3ds Max and all that. So you get the option to import and export from BIM platforms. So moving on, here we have the projects that are done with ProtaStructure. So here, okay, we have an eight-story building design. This building design and analysis was actually done using the ProtaStructure software. As you can see, it has been successfully done. I think it's a hotel building, so it has been successfully done, um, analyzed and designed using the software ProtaStructure. And here we have a steel warehouse structural design. So basically, this is just a steel um, warehouse that has been designed in ProtaStructure. You can notice the bracing members, your beams, columns, your rafters, and others. Okay, so here we have a culvert design, and here we have a structural design of three-story building on raft foundation. Yeah, so here we have a 9 meter tall steel overhead tank that is designed here in ProtaStructure. Yeah, it carries up to 36 meters cube of water, and it's an overhead tank, so you can see it was well designed here successfully in ProtaStructure. So here we have a bridge design, and moving on, a five-story commercial building design, and here we have raft foundations slab analysis with finite elements. This is simply um, a slab model of a RAS foundation. Now, knowing that your RAS foundation, I mean your slab in a RAS foundation, actually contributes to the strength of your foundation in a RAS foundation. So we had to analyze the slab using the finite elements method of analysis in order to make sure of accurate results. Okay, so we did that using the ProtaStructure software. So you can see the results of the detailing and all that. So moving on, we have the structural design of building on pad foundation. So this is simply a one-story building on pad foundation. So we have culvert designs, and we have a two-story building that is also sitting on a pad foundation. So moving on, here we have careers as a Prota or being software professional. Now, when you have now successfully mastered this software very well, what are the careers that you can actually pursue knowing this software? Okay, so you can go on to become a structural engineer or designer, a CAD designer, detailer, a structural designer, and then of course a construction professional. So industry where these structural skills can be applied. So we have the construction industry. Of course, the structural design skills is always needed there. And here we have the engineering field. Different engineering field actually requires the structural design. And here we have architectural companies and infrastructure development and all that. So here, ProtaStructure fundamental course curriculum. So throughout this training, this is what we are basically going to be looking at. Like this is the overview of what we are going to be going through. So we are going to start with familiarizing ourselves with the ProtaStructure environment. That is getting started with ProtaStructure. Then building, modeling, and loading. Then we now analyze and design our building. Then move to the substructure, and then after that we can now find ways to explore the detailings and reports. So day one, today is the day one on this of this training. So this training is actually going to be split into three different sessions, and today is the first day. And today, what we are going to be looking at or covering here is the introduction, user interface, and setting centers. Then after that, we move on to axis creation, properties, modification, and then we now explore the orthogonal axis generations. Okay, then we now move to external reference drawings, DXF imports, and then we can now start off modeling by placing columns, creating columns, and exploring its properties as well. So at the end of this training, so we are going to be providing you with assignments. So get any complex or simple architectural plan and do a general arrangement drawing and grid creation. So we are going to teach you that so that you can be able to have your assignment and go on with that. So the learning objectives. So at the end of this class, students should be able to use different methods to draw and create axes, modify axes, get familiar with external reference drawings, model reinforced concrete columns, and explore the different properties. Okay, so now let's jump back straight into our ProtaStructure software. Now, when you open the ProtaStructure software, this is what you are going to get. This is the interface um, that you are going to get. So this is actually the welcome screen. Okay, so I'm going to be using the ProtaStructure 2025 version for this illustration. But if you are using the ProtaStructure 2022 version or 23 or 24 and all that, so you are still going to be able to find your way around that because it's just little or no significant changes that is made on their updates. Okay, so the knowledge you're going to get from using from this 2025 that I'm using for this illustration is going to be applicable. You can still apply that using any other version. Okay, so here is the welcome screen. When you open up the software, this is what you will get. So you might notice if you are still opening this ProtaStructure for the first time, you're going to notice that this region on your screen, you're going to notice this region on your screen is going to be like is going to be blank. Okay, so that is because you have not actually done any projects here. So here is just basically for recent project. These are just basically some of the project that I just did recently, and then you also get this option that says open a project. That is to open a project that you have been working on, and here obviously you're going to get this option that says new project, which allows you to start up a new design project from scratch. Okay, so here we so without wasting any much of our time, so let's simply click on new project. So when we have clicked on that, we are going to get this dialog that allows you to input a project name. It says here project code, but it's simply it's just the name of the project that you would want. So let's input any name. So in this case, I'll just say um rent is not that important. It's just a name, rent training. Okay, so after that, the next thing you have to do is that you have to choose a design code. Here we have some sets of code, design codes that are um, that you can actually use for our design. Okay, so I believe that by now most of us have actually come across what a design code is. So but in case if you have not come across that, design codes are kind of set of rules or guidelines or even standards that kind of outline the requirements and best practices for designing buildings or structures. So these design codes are actually created by different countries and regions, and they align these codes and the guidelines they provide there specifically to their country standards. Okay, so the code that we use in Nigeria is the United Kingdom Euro code. So that is the code that we basically use for RC designs. That is Euro code 2 for our reinforced concrete design. So formerly we would use the British standards, but it's become obsolete in 2010. So what we currently use now is the Euro code here. So you can say United Kingdom Euro code. So if you are joining us from any part of the um, world, let's assume you are joining us from Malaysia. So you have the option to use the Malaysian BS code, or from Colombia, you can use Colombian code. So just make sure that the code you are choosing must relate specifically to the region that this building is going to be um, built at. Okay, so let's say Euro code and then say okay. So we are going to give the software like 2 or 3 seconds to open up the ProtaStructure interface. Alright, so this is the ProtaStructure environment. So this is what the interface looks like. So when you open up this, the first thing that you're going to notice is this sheet that is your modeling screen on this region right here. This is basically your modeling screen. So everything that you do, so anything that you do is going to be done here, your modeling screen. Just this area, you can use your mouse wheel to zoom in or zoom out if you want. So here is where we are going to be doing basically most of our modelings. And then you're going to also notice by the left side of your screen, we have your structure tree here. So in this structure tree, this is where every model, I mean every member that you have modeled is going to be shown. So whenever you model any member, any single member, be it a column, beam, slab, or any member axis as well. So it's going to report itself to its respective folder here in the um, structure tree. Okay, so here we have the folder for axis, we have here for columns, beams, shear walls, and even for different stories. So we can't open that up, we can't select any one of them. That is simply because we have not done any modeling yet. Okay, so but you also get this story 0 and story 1 by default. So you still have the option to add multiple stories when you want, um, depending on the number of stories that you are going to be designing for. Okay, so moving up to the ribbons. So in this region here, this is where we have your menu bars. So in this your menu bar, we have your building setup tab, and here we have your modeling tab, loading tab, and others. So in your building setup tab, this is basically where you um you set out your building and how you would want it to look like. Okay, so we have this option that allows you to open a project or a new one, and you have this option that also allows you to close the project and save your project if you want. So you also get this option that allows you to use external reference drawing, setting centers, and all that. This is basically where you set out your building. Moving on, here we have your modeling tab. So here this is where we get all the tools that we are going to be needing to perform your modeling, all the tools you are going to be needing. So here we have the grid tool, and we also have some drawing tools here, line, arc, circles, and all that. So here you get the option to draw some shapes and then assign columns or members to them. And here, of course, we have your um, reinforced concrete members section, this region right here. So we have our columns, RC walls and beams, slab, grid slabs, and all that. So here, this is where you actually find the different column I mean the different members that you are going to be using for your modeling, so you can pick each and every one of them out here um, as you would want. And so here we have your steel members. So your steel columns are here, your steel frames, trusses, domes, girts, purlins, your bracing members are there as well. And here you also get this option for the support types, seismic isolators, and all that. So in this training, we are going to be covering most of everything that we are seeing here. So by the end of this training, you are going to be able to do some basic modeling and design of buildings. Okay, so we are going to be covering all these things um, step by step, one after the other. So after modeling, we have your loading. So you have your loading tab, and here this is where you assign different loadings to your building members. We have your load case combinators, wind and story loads, partition, wall slab, additional loadings, and others. So moving on, we have your review functions. So here is where you go to check after modeling your structure and loading them. This is where you go to check that they are well aligned in the places they are supposed to be, and check for possible errors and all that, so that it's not going to affect your building during analysis or design. So and after that you move on to analysis. Here we have different analysis options. We have the building analysis, we have load decomposition by finite elements, we have um, various options that you can use here for your building analysis. Then you have your design tab. So now you are going to notice that these menu tabs are actually arranged in the same way that you are going to be proceeding with your building design. So first of all, you do your building setups, then you model your structure, you load them, you review them, then you analyze them, you run analysis, and then design. So here we have different options for designing, performing some kind of interactive design checks, sizing your columns and beams and all that. Here we have the drawings and report tab. Here is where you produce the different drawing working drawings for your design buildings. And here we have the BIM display options and then the view options. Okay, so without wasting much of our time, let's simply go into our modeling. So the next thing on our agenda is axis. We have already treated introduction, the user interface, and the next thing we are going to be treating is axis. Axis creation, axis properties, modification, and then orthogonal axis. So now axis. Axis is the first step of modeling. So you cannot model your columns, your beams, shear walls without having created your axis, because it is at the intersection of different axes that you can actually place your um, columns, your beams, and all that, every one of your members. Okay. So now moving on, there are basically three different ways that we can actually create our axis or grid. The first step is simply by going to the modeling tab over here, and then you are going to find this grid icon that is using the axis toolbar. So this is actually used to create axis simply by it's actually used to create individual axes just simply by um, clicking on the modeling screen. Okay, and the second way of creating axes is using this orthogonal axis generator. Okay, this is actually used to build a system or like a group of axes quickly by specifying the distances between this axis and the number of axes or the number of spaces that you want to be created. Okay, so now let us now start creating our axis. The third way is by using the XF import and then tracing down your axis, but you are going to explore that in our um in the coming during the course of this lesson. Okay. So now let us now use the first step, which is by using the grid icon here, which is by using the axis toolbar. So when you now click on it once, you are going to get this properties dialog. So this is simply the axis properties dialog that is showing the properties of that particular axis that you are going to be creating. Okay, you can drag that and then dock it anywhere you want. So let's just dock it to the left, just like so. Okay, so here we have the axis label, the level in which you want the axis to have at the ribbon head, and here we have the visibility. Okay, let's check it so that it can be visible while we are creating it. And here we have the length is not shown because we have not actually created this. And here we have three basic insertion method. Let's just say it's three insertion method for our axis creation. So the first one is single segment axis insertion method. We have this multi segments, and here we have the curve axis insertion method. So it's very simple. Okay, do not panic. So let's simply click on the first um, insertion method we have here, which is the single segment method of axis insertion. Now when you have clicked on that, now to create your axis, simply click on the first point of placement or insertion, and then click on any second point of placement or insertion, and then we are going to have it. So we have now successfully created our first axis. So it's a horizontal axis, as you can see. You can notice the label here. The label here is it corresponds directly with what we have here on our properties dialog, and you can see the length is now showing. The length is 25,000 millimeters. That is the length of this whole grid or axis. And then the angle, it is placed at an angle 0 to the horizontal, as you would expect. Okay, so now let's further create more axes. This time, let us create an axis with a specified length, that is with the length that you would want. Okay, so now click on the first point of axis insertion. You are going to notice this grayed out elastic function showing on your screen, as you would expect. Now type F2 key on your keyboard. Just press F2 key on your keyboard. When you do that, you are going to get this option that allows you to input the axis length. So You have the option to input any length that comes to your mind. Okay, so in this case, let's just say 20,000 millimeters. The unit is in millimeters. So when I've done that, I can now click enter. So when I do that, I am going to get this option. Okay, so now hold down your control key in order to place it at a directly horizontal plane. Okay, so just hold down your control key. It's going to snap to the horizontal, and then finally click. And then when you have now finally done that, you are going to get this axis with the label B, and then the length is 20,000 millimeter, just as we have specified. Now let us continue to create more axes. Now to create um, an axis that is inclined at an angle to the horizontal, okay, that is diagonal axis. So that is very, very simple. So what we can do, first of all, click on your first point of axis insertion, and then type F2 key on your keyboard. Just hit F2 key on your keyboard, and then press the length of axis that you would want. So let's say 20,000 millimeters, or rather let's say 15,000 millimeters, which is 15 meters. Then press tab on your keyboard first. So when you have now hit tab, you are going to get this option to now input the angle that this axis is going to be inclined to the horizontal. Okay, so now let's assume maybe 30 degrees, and then say enter. So when we have done that, you are going to notice that we have now successfully created this diagonal axis. You can see in the properties dialog, it says length 15 thousand millimeters and angle 30 degrees. So here we can see the level of the axis to be C, as, as it corresponds very well with the one we have in our property dialog. Now you are going to notice something. While you are creating your axis, the first one that you are going to create usually starts from A, and the following one starts continues with B and C, and it goes on the same way. Okay. Now press escape key to get rid of the axis creation tool. Now we have now successfully created three axes. So let us now further create a vertical axis. So in case if you didn't get it the first time, simply go to your modeling tab, then click on the grid icon. Now we are going to have this option. Okay, so now to create a vertical axis, simply click on the first point of insertion, and then hold down on your control key to ensure that the axis is straight, and then click on the second point of insertion. So when you have done that, you are going to get this. It's very, very simple, just like what we have done before. So you can see the angle with this one is inclined to the horizontal is actually 90 degrees. Okay, that's very reasonable. And here we have our length with 22,300 millimeters. So what we can also do, we can choose to create. So now let's just create a vertical axis or grid that has a specified length. So to do that, we have already clicked at our first point of insertion. Now let us now um, press F2 key on our keyboard and then input the axis length. So in this case, let me say um, 10,000 millimeter, which is 10 meters, and then say enter. Then hold down our control key to make sure that it's aligned to the vertical. Yeah, so we have now actually clicked that. So this is what we get. So it's now saying 1. So I have the option to now change the level to whatever I want. So let's assume I want the level to be um 5, for instance. Okay, so I can now click 5 here and then say update. You are going to notice that when I click this update, it's going to update here automatically. So let's say update. So you can see now this axis has now been successfully updated. Okay, so now let us now create a multi-segment axis. Let's now use the multi-segment system of insertion to insert axis. Okay, so now to do that, first of all, I need to delete all these axes. So to delete an axis, what you can simply do is to select that axis you want to delete. Just click on that and then press delete on your keyboard. Or alternatively, you can also delete axis by selecting an axis, then right click and then say delete. Then alternatively, to do that faster, you can select all the axes that you would want to delete, then press delete key on your keyboard, and then you are going to have this option that allows you to confirm that and then say OK. So we have now deleted that. So now let's now create a multi-segment axis. So a multi-segment axis is used to create a single axis with multiple segments of any shape. It's going to be kind of broken. So if you want to create a kind of axis that is going to be triangular or trapezoidal or of any shape at all, so you can use, instead of creating multiple axes in different angles, you can simply use this multi-segment axis insertion method here. To do that is going to be more efficient for you. Okay, so now to do that, click your first point of insertion and then you're going to get this elastic function as you would expect. Now click on the second point of insertion, then you're going to notice that you still have that tool to continue creating axis. Now you can now continue clicking at anywhere you want in order to continue creating your axis, and you can make it look any shape you want at all. So when you are done when you are done um, drawing your multi-segment axis, simply right click to end the process. Okay, so now we have now successfully created this axis. Okay, now let us do that again in case you missed that. So now to create a multi-segment axis, click on the first point of insertion, drag out. Now click on the second point of insertion. So alternatively, you can also impute an actual length if you want, and then an angle. So in this case, let me use the F2 key. So I get the option to impute a length. So let me say 10,000 millimeters, and then press tab key. Don't press enter yet, press tab and then impute an angle, specify a desired angle. So in this case, let me just say 60 degrees and then say enter. Now I still get the option to continue placing, so I can equally place anywhere I want. Let me now hold down on the control key to make sure it's straight. So let's place it there. Now um to undo a recent point that you have just placed at the axis at, so you can just press the escape key. The last point that you just placed will be on place just like that. Okay, so let's continue. So let's place here. So let me use F2 key and let's assume a 10,000 millimeters of length. Say enter. Hold down on control key to make sure it's straight. Okay, good. Now finally click outside and then right click to end that. So this is what we now have. Okay, that is looking very good at the moment. Now let us now create a curved axis. So this curve axis insertion method is actually used to create curve axis by specifying the um, offset distance. Okay. So now to create that, simply click on your first point of axis insertion and then click on the second point of axis insertion. Then you are going to get this that allows you to impute the offset distance. So you can just simply click uh, anywhere to have your curved axis already created just like so. Then alternatively, you can do that again. Hold down on your control key to make sure it's straight, then click there. Now press F2 key on your keyboard in order to impute um, a desired offset distance from the center of that arc. So let's assume 10,000 millimeters as the offset distance and then say enter. So when we have clicked that, this is what we are going to get. So now we have now successfully created our multi-segment axis and our curved axis. So now this multi-segment axis and this curved axis are very useful when you want to create a crank beam or a bent up beam, because when you create a beam along a multi-segment axis or a curved axis of any shape, a single beam will be created rather than having multiple beams joined. It doesn't really help analysis a lot. Okay, so now let's continue. So the next thing we are going to do is that we are going to explore the different functions and properties of axes. Like we are going to explore the different ways we can modify them. So to do that, let's delete this and let us now create. So now the next thing we are going to do is that we are going to explore different functions and properties of axes. So let's create a horizontal axis. So I already created three horizontal axes. You can do that if you have not already done so. Now, when you select and right click on an axis, you are going to find this option. This option appears, which shows you the different ways you can modify this axis and the different things you can be able to do with this axis. You can choose to explore its properties. You can delete that, you can mirror that to the other side. You can offset that, move, rotate, stretch axis, and all that. Okay. Now to offset an axis, you can simply select on an axis, right click, and then say offset. Now, when you want to offset it upwards, just simply click that at the side you want to offset that, simply just like so. So you get this option that allows you to continue offsetting the axis. You can press escape key to get rid of that. Now, right click again, and let's do the offset again. Right click on this axis, select that, right click, and then say offset axis. Press the F2 key on your keyboard to input an actual offset distance. So let's say in this case 2000 millimeters, and then say enter. Okay, very good. So I can also choose to say F2 key on my keyboard. Let's offset this by 10,000 millimeters. Okay, and then press escape. So this is what we get. Now let us now offset this downwards. So when we want to offset an axis downwards, just like what we have in your graph, if you are going upward is positive, and when you're coming down is negative. The same thing when you're going to the right is positive, and to the left is negative. So if I want to offset this axis downwards, not upward this time, just simply select the axis, right click, and then say offset axis. Then you are going to get this. So press F2 key on your keyboard. Now instead of pressing 2000 millimeters, what I am simply going to do, I'm going to click minus 2000 millimeters in order to have it just like so, in order to offset it downwards. So when I press enter, so I'm going to get this axis. um, I'm going to see that this axis has been offset downward with at a distance at 2000 millimeters. So I can press F2 key on my keyboard to input another distance, let's say minus 3000 millimeters, and then say enter. So that is how you can successfully offset your axis. Now to move an existing axis, simply select the axis in which you want to move. Just assuming I want to move this axis, simply say click on it, then right click, and then say move. Then you can drag that and drop it anywhere you want. And this axis has now been successfully moved. Now to rotate an axis, what we can do is just left click to select axis, and then right click, and then you are going to get the option that says rotate axis. Then click on that, and then click or select a point in which you want to be the pivotal point, that is the point of rotation. So you can choose to rotate from the midpoint or from the end point or anywhere you want. So in this case, let me just say the midpoint. Okay, Let me click on the midpoint. So I will get this elastic um, function again. So I will have the option to impute the angle of rotation. So by pressing F2 key on your keyboard, you can now be able to impute the angle of rotation. So in this case, let me assume 30 degrees and then say enter. So this is what I've now successfully created. Now finally, what we can also do is to stretch axis. So now to stretch axis, what you can simply do is select the axis you want to stretch and then right click and then say stretch axis. Simply click on that and then um, click on the points that you want to stretch. So let's drag this point out and then click elsewhere. Okay, so we have now successfully stretched this axis just like so, just like we have it. Okay, so one other thing you are going to notice is that whenever you select axis, any element, so instead of right clicking, you can look at the ribbon up here. You can look at the ribbon up here. You are going to see pretty much every all these other options that we have seen before by right clicking here. So this is another place you can use to access the modification properties. Okay, so here we have the offset axis, move offset axis to move to rotate axis, stretch axis, and we have also explored each and every one of them. So we also have this option that allows you to stretch axis to member intersections and stretch axis to a boundary. Okay, so that's simply stretching axis as you would expect. So that is how to um create axis, and that is how to modify your axis. You want to change the position, you want to offset and create multiple ones. Okay, now we are also going to notice this dimension line that is added by default automatically by the software, by the program. Okay, so whenever you create a system of axis, you are going to get this um dimension lines that tells you the distance between each and every axis that you have created. Okay, now let us create a vertical axis. You can do that if you want. So I believe that is a very easy thing. So now to do that, click on an axis. You can go to the modeling tab and then say grid, and then you can now start creating. Or you can take the properties of this simply by selecting the axis and then going um to the panel above and then say properties. So and then you can now start creating. So we can have something that looks like this, and then we can offset this if you want. So to offset this to the right, simply click on the axis and then say offset axis over here, and then we are going to get this option to choose which side we want to offset it. Now press F2 key on your keyboard to input an actual offset distance. Now I want to offset this axis to the right, so I'm just going to input the offset distance. Let's say 5,000 millimeters, and then say enter. So we have the option to continue to offset that and until we have that slide. So then press escape to get rid of that. Now to offset this axis to the left, what I can simply do is to select the axis, say offset axis, and then press F2 key on your keyboard and then say minus 5,000 millimeters and then say enter. So as you can see, the axis has been offset um the other side of it. Then press escape to get to stop the axis offsetting function. Okay, so let us now create orthogonal axis. So remember I said you have three different methods of axis creation. We have now explored how to use the axis toolbar. Now let's now find out how we can now use the orthogonal axis generator. Now to do that, what you can simply do is to go to the modeling tab and then click this icon that says orthogonal axis generator. Now when we have clicked that, what we are going to do is to click at any point we want on the modeling screen. Just click at any point. Okay, so now we are going to get this orthogonal axis generator dialog that allows us to input um the different parameters, how we want this orthogonal axis generator to look. Remember I said that the orthogonal axis generator tool is used to build like a system of axes for a group of axes automatically just by input the distances between these two axes. Okay, now we have here the reference point. The reference point is typically where I just clicked initially, and here we have the insertion angle, so let's leave that at 0. So we have the direction 1 axis and direction 2 axis. So what we mean by direction 1 axis are axis in the horizontal direction, and direction 2 axis are axis in the vertical direction. Okay, so the axis in the horizontal direction, which is direction 1 axis, this is the level that we are going to be following: A, B, C, D, and the rest. And here the step says 1, so let's leave that as 1. So the axis spacing we have here to be 5000 millimeters, and then the number of spacing that we want between these axes, we have that by 3. So this is usually denoted by, you know, um imputing the space, the distance you want between the axes, and the number of distance you want. So the first is the distance you want, and is separated from the number of spaces you want by the asterisk symbol. So in this case, let's assume that I want the distance of 4000 millimeters and separated I mean at a number of in 5 different places. Okay, so I can just have that just like so. And for the direction 2 axis, I can do the same thing over here, and three let's assume here 3000 millimeters um in spaces of 6. Okay, and then say okay. So our axis is going to appear here automatically, so you can see what we did um for the way we set that up. So that is the way it actually appears here. You can see our direction 1 axis, which is our horizontal axis. It was denoted, the level was going to be alphabetically. Okay, it was going to be labeled alphabetically. So we have here A, B, C, D, E, F, G, um, E to F. Okay, so here we have 1 to 7 for our direction 2 axis, that is our vertical axis. Okay, and then we can also observe this dimension line that has also appeared for our axis, for axis. Okay, so we set that to 4000 millimeters at a spacing 1, 2, 3, 4, 5. So in 5 different spaces of 4000 millimeters, the same thing goes for our vertical axis. So this is a faster way of building a system of axis by using the orthogonal axis generator. So there are many other ways that we can use this orthogonal axis generator to build a group of axes that makes it more complex and all that. So we are going to be exploring that during most of our advanced classes, and we are going to be teaching all this. Okay, so let's move. So let's now learn how to draw axes by using the XF drawing, that is an external reference drawing. So this actually means importing an external reference drawing from any other 2D drawing software, maybe AutoCAD, and then importing that to ProtaStructure, and then using that to trace out your axes and draw them. Okay, so now to do that, simply go to your building setup tab, and you're going to get this option that says external reference drawing. Click on that once, and then click add, and then look for, browse your computer to look for where you have actually saved the XF file. then click that and then say open. Now an external reference drawing, um I mean the ProtaStructure only accepts an external reference drawing that is saved as a DXF file. Okay, so the ProtaStructure only understand the DXF file. You cannot import it from a DWG drawing. Okay, so now click on activate, click on active, check the active symbol in order to activate that, and then say use colors. So you can notice in the background it's already showing there, and say use colors to make the colors to be visible. Okay, so now this is what we have. So this is a project that we are going to be using for um this training and for most of our assignments. Okay, so we are going to be using this DXF file. So it's going to be available for you to download. It's going to be shared to everyone who has access to this video. Okay, so you are going to get the option to download this particular DXF file and use it to follow suit with what we are doing. Okay, now so this is a project that we have been working on, that we are going to be using basically for this training session. Okay, so here we have our, these black lines are actually our grid lines, and these blue lines are represents our beams. And you are going to find some red rectangles, red squares. This actually denotes our columns, and then this green here is our shear wall. So you are going to be using this the Excel file to model our building. Okay, now so now to create an axis using this Excel file, what we can simply do is to go to our modeling tab and then click on the grid icon. Okay, so now let us now start tracing down our axis. So hover your point at the end of this line, so you are going to get this option that snaps it at the endpoint. So click on that and then drag it down and then snap it to the other endpoint. So by default it's going to be labeled A. You have the option to change the label if you want. So let's just leave it just like so. Now let's now continue creating um every other axis. So I mean this is more efficient like this. So you get to have the actual distances just the way it's now created in the drawing. Okay, so just continue doing that just like so. And then finally, let's create this one. So we have now successfully created the vertical axis. So now to create this horizontal axis, so let us now simply change the label to 1 so that it can be able to be numbered numerically instead of alphabetically. Okay, so let's start from here. Okay, we have that 1. Okay, here should be 2. So it says H, let's change it to 2 and then say update. So you can have that just like so. Then let's continue creating. Here should be 3, and here 4, 5, 6, and then finally we have this here. Okay, so this is what it's supposed to look like when you are done creating your axis. So what you can do is that you can turn off the DXF, I mean the external reference drawing. You can turn it off so that you can be able to see that clearly. So simply uncheck this option that says active and then say OK. So we now have only our axis placed just like so. And then one thing that you should have noticed is that each and every time that we have created or modeled something here, it always shows in the structure tree. Like you can notice that all these axes that we have now created here, they all report itself um, to the axis folder in the structure tree. So you can choose to select an axis just by clicking here. You are going to notice that the axis is now selected. The axis with the label B is also selected on the structure tree. You can also choose to select an axis here directly on the structure tree. So if I want to select this axis, I can just simply select the tree on the structure tree, and this axis here is now automatically selected. I can choose to do anything with that. I can choose to stretch that, or move that, or anything I would want to do by using these modification options that we have here. So that is simply how to create your axis using that GXF drawing file. Okay. So the next thing on our agenda, so we actually treated this external reference drawing and the DXF import kind of simultaneously, but this DXF import has a more um, advanced approach in the way that you can use that not only to create your axis, you can also use that to model your columns and your beams and all that. So, but we are not going to be going into that right now because of our time, and it's a little bit, advanced. So, for your understanding, we are going to leave that for the time being. We are also going to treat that in the future as we progress. Okay. So here we have the columns creation and properties. That is the next thing on our agenda, which is the exact thing that we are now going to be looking at right now. So now to create columns, we simply need to go to the modeling tab here, and in the reinforced concrete um member section of the modeling tab over here. So here we have our reinforced concrete columns, RC walls, RC beams, slabs, roof slab, and slab strips and all that. So that is where you get your um um column modeling tools to create your columns. Okay. So now to create your columns, to create, okay, so your columns can be created using the column tool in the modeling tab. So go to the modeling tab here over here. So you are going to find this column tool in the reinforced concrete member section. So here it is, this column tool. So simply click on it in order to start creating your columns. So when you click on that, you are going to get this properties dialog that is going to be showing you the properties of your column. So here we have the label as 1C1, and here we have the length of story. We have the breadth, which is B1. B1 simply means the horizontal breadth of your rectangular column, and then B2 is the vertical breadth of your rectangular column. And here we have your eccentricity, E1 and E2, and most of us must have come across this eccentricity before, um, if you are a student in 400 level and you study civil engineering, so you must have come across advanced structural engineering. So in those places, um, you must have come across eccentricity. So we are going to be exploring and teaching that what eccentricity means and how you can actually use that in your structural modeling and also design. Okay. So, but for now, let's just create a very simple columns. Okay. Now to create a column, so take note that you can only create or insert your columns at axis intersection. So you cannot insert your columns at an empty place. So you can only insert your columns at axis intersection. So now let's leave the default settings as the B1 500 by 250 millimeters column. Now click on an axis intersection. When you hover around an axis intersection, it's going to snap automatically, and you're going to get this option that says axis intersection. Now click there once, and you are going to automatically have your column just like so. So you can continue placing your columns at any axis intersection that you want. Alternatively, you can also place your columns just by drawing a window selection, and every axis intersection that is enclosed inside that window selection that you have drawn, you automatically have columns placed inside there. So what I'm simply going to do, so let me just simply draw an axis, a window selection, just like so. Just draw and drag. So in this area, all the axis intersection here are automatically going to have columns inserted in them. Can you see that how it's looking? Okay. So here we can also observe in our structure tree under the story one, under the story one folder and under the columns folder. So we have here So we have here our story one, and then we now have this drop down arrow on this column, which simply helps to tell us that columns have already been created. So now let's just drop that down, and then we have here the different labels of all these different columns. Okay, so it has all reported itself to their respective folder. So we can now continue to place our columns by drawing this window selection, so that you can have columns here. And then alternatively, so here we have this 500 by 250 millimeters column. So if you want to change the distance, I mean the section properties of it, so we can come here and then say, let's assume we want a square column 250 by 250, and then say update. So we have already selected this column, just simply say update, and then it's going to update automatically. You can see one column 28, 250 by 250. It is well denoted here, so we can continue to place that anywhere we want. So we can continue to have that like so. Let's draw a window selection to have that place just like so. Okay, now when we are done creating our columns, we can simply say close and then close the properties dialog. So now let us now go to the 3D view so that we can see what we have now successfully created or achieved. Now to go to the 3D view, there are two different ways you can do that. Simply go to your structure 3 panel, and then um, open up the views tab, then right click on that. You are going to get this option that says 3D physical model and 3D rebound model. Just click on the 3D physical model in order to get the 3D view. Alternatively, you can also go to your menu bars in this option that says views. Simply click on that and you are going to get this option that says 3D physical model as well. Click on that. Is the same thing, is going to give you that. So here is the 3D representation of the um, members that we have just modeled, of the columns we have just modeled. So you can right click on your mouse, just right click on your mouse and then drag that so that you can be able to pan that. Just hold right click and then shift that so that you can be able to rotate the model to see what it looks like. You can use your mouse wheel to zoom in and zoom out. So here we can find our axis and then our columns that we have just modeled. So we also have here our columns that are 500 by 250 millimeters and also our square columns as well. Okay, so this is what we have created and this is what it looks like. Okay, that's very perfect. So now let's go back to our plan view. Now um to delete your columns, so I want to actually delete all these columns so that you can actually model these columns in the way that it is supposed to look. Okay, now let's simply delete these columns. Select them by just drawing a selection windows on them and then press delete on your keyboard, and you get this option that allows you to confirm that, and then you can say okay. So now let's go back to our building setup tab and then click on the external reference drawing tool and then say activate and then say okay. So when we have now activated that, we are going to be getting this external reference drawing. It's still placed at that position where we placed that initially. Okay, we are going to notice this small rectangular red lines. They actually denote your column. That is where we want to be placing all our columns. Okay, so where we have all these rectangular red lines, that is where we are going to be placing our columns. Okay, very good. So now to start placing our columns, simply go to the modeling tab select columns. When we have now selected our columns, we are going to get this option to we are going to get the option to set the section properties. So this columns here was actually set to 225 by 225. That is 9 inches by 9 inches column, um, um, which is the typical size of column that we use in most of construction around the country, around Nigeria, for all these basic building and small buildings. Okay, so that was what was set for this column. Okay, so let us change the breadth and the width of the column to 225. So simply go to the B1 and say 225, and then come to the B2, say 225. Now start placing your column at the places you want. Okay, we have already placed here. Now let's place here. Okay, so at every red lines that you would want, place here as well. Place here as well. Okay, so I want to believe that most of us um are still students, and that means most of us may have also graduated from the university. So that simply means that I expect us to have some basic understanding of most of the engineering terms um, that we use, like all those bending moments, columns, shear force, the manual principles to reinforce concrete design. I expect us to have come across that. But even if you have not come across that, you don't have to panic, because while we are teaching the software, we are also going to be explaining the manual principles. Okay, so we are not just going to be showing you modeling, and then going through the going through the software. We are also going to be providing some manual principles that helps in structural designs and what you need to be doing in order to become confident in your design that you have produced. Okay, so let me continue placing our columns in the regions where we need them. Okay, we have here, and then we have one here. So then we have one here, and then we have one here. So we have now finished placing that. So now let's close up this properties dialog, and then go to the 3D view so that you can see what we have now successfully achieved. So this is our column that we have now successfully created. So we also have the standard reference drawing here showing in the 3D view. So we have the option to turn that off if you want. So let's just leave it for the time being. So go to the views tab. You get this option that allows you to tile your views vertically and horizontally, or in any way that you would want to tile that. So let's just say tile vertically so that we can be able to view the 3D and the floor plan view at the same time. Okay, so here is what we have, and this is looking very exquisite. Now let us now turn off the external reference drawing. Let's turn it off, then say okay, so that we can now have this our columns and our grids alone. So don't go anywhere. By our next class, we are going to be covering the modeling aspects of building. So we are going to model this building from the from the ground floor up to the final floor. It's actually a two-story building. So we are going to show you how to model each and every member of the building, both the beams, the slabs, the columns, and the roof beams, and even the part footings. Okay, so we are going to be showing you that here in our next lesson. Okay, so don't go anywhere. Have a nice day and God bless you.